Ever wonder why everyone's always saying don't touch electrical stuff with wet hands? And why do we see those crazy sparks whenever water gets too close to wires? What exactly is going down inside the water when a current passes through it? There are so many questions buzzing around about the relationship between electricity and the tap water we use every single day. The water you're grabbing from the tap or seeing in a river isn't actually pure. It's packed with dissolved salts like sodium chloride and minerals such as calcium and magnesium. These substances break down in the water into charged particles called positive and negative ions. And when electricity hits that water, electrons just zip right through those ions instead of sticking to the copper wire. It's wild. Those ions basically turn into mobile bridges that carry the charge from one spot to another with total ease. Plus, the electrical resistance of regular water is super low compared to dry air. It's actually less than 1000 ohms per centimeter. This means that electricity would totally prefer to travel through water rather than the wire if it gets half a chance. So, if water touches a bare electrical wire, the current leaks out toward the ground or any nearby conductive object. The electricity is always hunting for the path of least resistance, just to complete its loop and get back to the source. And that leakage is exactly what gives you an electric shock if you're standing barefoot on a damp floor. For example, when someone touches a metal faucet connected to the ground while also touching a faulty electrical appliance, their body literally becomes part of the circuit. As for the spark you see when plugging in a device in humid air, it happens because the electrons jump across a tiny air gap forming a mini electric arc. That arc heats up the air instantly to thousands of degrees Celsius. And this jump happens because the water molecules in humid air actually help ionize the air atoms. The electrons crash into nitrogen and oxygen atoms, which kicks off new electrons and turns the air into a temporary conductor. If the humidity gets super high, that electric arc sticks around for way longer and can even turn into a continuous spark. That is exactly why you sometimes see a cool blue flash when unplugging powerful devices in steamy bathrooms or humid kitchens. And that dimming light you sometimes notice when water touches electricity happens because a chunk of the current is getting lost through the water. As a result, the voltage reaching the light bulb drops, and it just cannot put out enough light. If a path of water forms that connects the hot wire and the ground wire directly, you get what we call a short circuit. The current completely bypasses the light bulb and zips along the easier path through the water, so the light just cuts out instantly. Also, the intensity of the current running through the water totally depends on how much salt is dissolved in it. For example, seawater, which has a salinity of over 35 grams per liter, conducts electricity way more strongly than regular tap water. And that distilled water you grab at the pharmacy has practically no salts in it, so it's actually a solid insulator. But it turns into a conductor super fast if it gets mixed with any dust or just a tiny bit of salt from the air. Since just one tiny drop of water on a delicate circuit board can totally wreck it. The electrons take a path that was never meant to be through that droplet and end up frying super thin copper tracks that you can't even see with the naked eye. So, if you want to keep your gadgets safe, just make sure your hands are totally dry before touching any switch or outlet. And remember, safety really starts with understanding the relationship between water droplets and the fast-paced journey of electrons inside those wires.